Yes, ma'am.
All right. So yes, in the last class, we started with EMI and magnetic flux was the topic that we discussed. So I told you to read about Faraday's experiments, which we have already done it in the class. So basically the conclusions of Faraday's experiments were what? That whenever there is a relative motion between the source of magnetic field and the coil, EMF will be induced, and induced EMF is associated. Now, when we did the experiments, if you remember, we had seen the case when the magnet and coil move towards each other, then the flux linked with the coil increases. And when this increases, EMF is induced in the circuit. Now, when the magnet and coil move away from each other, so magnetic flux decreases, again EMF is induced. So basically, we could conclude the fact that whenever magnetic flux increased or decreased, there has to be a change in magnetic flux. When the change in when there is a change in this magnetic flux, there is an associated induced EMF within the coil, and this EMF lasts so long the flux is changing. Till the time the flux is changing, it will keep on changing. One more thing that because of this EMF, electric current will flow. See, EMF is there and the circuit current will be there. And this current is detected by the device that we have, which we call as, what is the device which detects current?
Galvanometer.
Galvanometer, perfect. So galvanometer shows deflection. And deflection in the galvanometer lasts as long the relative motion between the magnet and coil continues. Till the time, why? Because see, when there is a change in magnetic flux, then only there will be an EMF induced, and then only there will be a current in the circuit, right? So if there is no relative motion between the magnet and the coil, magnetic flux won't change. So that's why this current will be present when this component is present. So all these are linked to each other. And whenever relative motion between coil and magnet takes place, induced EMF is produced. All right. So this entire phenomena is known as electromagnetic induction, which is your lesson, electromagnetic induction. And this was given by Michael Faraday. This is, you should remember. And it was the reverse of Oersted experiment. Oersted experiment is not important. Faraday's laws of EMI, you should know. What were the laws of Faraday's EMI? So see, basically his first law was that whenever there is a change in magnetic flux, associated induced EMF is present, whose magnitude, second law says that. So first law is this: whenever the amount of magnetic flux linked with the closed circuit changes, there is an induced EMF associated in the circuit, or EMF is induced in the circuit. And this will be present till the time magnetic flux is changing. So change in magnetic flux is the cause of it. Second law says that the magnitude is directly proportional to the rate of change of magnetic flux. So the first law is about induced EMF. Second law is about these. And these are which laws? These are Faraday's laws of electromagnetic induction. Now, when we conclude the fact, we know Lenz's law is present, and Lenz's law basically says that, see, because this law is incomplete without the interference of Lenz's law. Now, Lenz's law says what? See, he was basically he was a Russian scientist, and he was giving his samples and discovering the direction of induced current. So in the meantime, he got to know about Faraday's law already. So he knew E is directly proportional to d phi over dt. But what happens to their signs? At least he got a clue from Faraday's experiment. So around the year, I think around 1835, exact year, yeah, 1835 it was. So he discovered this Lenz's law was given, but that is of no use to you. With years and all will not come. What will come is that, see, Lenz's law basically says that the direction of induced current direction of this induced current is always in such a manner to oppose the cause that is producing it. If this is produced due to increase in magnetic flux, magnetic field will be set up in such a magnetic field will be increasing. That's why flux is increasing. So induced direction will be to decrease the flux. This is the whole story. And if you go reverse, if magnetic flux is decreasing, magnetic field is decreasing, it will try to increase it. This is the whole vicious cycle around which entire Lenz's law revolves. So because of this, we have this formula, which is very useful. E is equal to minus n d phi over dt. And for phi, you can use this also, minus n phi 2 minus phi 1 also by the change in time. This also you can use. And that entire, I'm not going to repeat, that we have done when North Pole is coming, so anti-clockwise or clockwise, and that. And just remember, it is a consequence of conservation of energy. This is very important for both of your exams. Conservation of energy. Because the reason, let me tell you why this is based upon conservation of energy. Reason is also very simple. You should just know the basic reason. Reason to this says that, see, entire thing is clear. The direction of induced current according to Lenz's law is always opposite to the motion of the magnet and all. Basically, whatever is the work done in moving this magnet, work done in moving the magnet, this work done gets converted into electrical energy. So there is a conservation of energy. The work done is getting converted here. All right. So this energy, this can further be dissipated as heat in the coil. That's a different thing. But induced current will always flow in opposite direction in conservation to energy. This has come a lot in the exams. One of the easiest question, but the options will be in such a manner that sometimes it will be confusing. So always remember conservation of energy. Fixed reason also. Now you know reason is simple. This reason is sufficient. All right, this is what you should remember, all the points. And one more thing. See, just some points which are essential for your numericals that I want to tell you. Firstly, one more thing. This EMF, no, this induced EMF. This will never depend upon the nature of the coil and resistance, because these types of questions also come. 4 options will be there. So it will not depend on nature. Nature of the coil means the material it is made up of, and therefore the resistance. This is an important point which you should remember. And one very important point which can be helpful for your numericals is that EMF is directly proportional to the relative speed of the coil magnet system. All right. Current depends upon resistance. This is independent, but when we talk about induced current, this depends upon the resistance. This depends upon the resistance, but induced EMF does not depend upon the resistance. All right. So that's why there is one more condition, that this is the reason why EMF exists in open circuits. If you remember, when I had told you what is meant by EMF, what is the difference between EMF and terminal potential difference, that time I mentioned the fact open circuit. The reason behind this being a part of open circuit is that the induced EMF is not depending upon the nature and resistance. The main point is the resistance, because we know according to V is equal to IR. If you go by this law, you know that V by I, the product is a constant, that is resistance. So if this isn't present in your circuit will behave as an open circuit. So if you people remember, I had made you write a point differences between EMF and terminal potential difference, where the major difference was because of open circuit and closed circuit. So this is the reason behind it. All right. So this tells you about the open circuit, that it exists. Always remember, it does not depend upon resistance, but it will be existing in the open circuits. All right. This is what you should remember. Rest of the things we have already discussed, and rest of the things are very basic, easy. These points are important, especially this point, work done. This is important for your CBSE part also, not just for your JEE. This is asked in CBSE also sometimes. Let us practice also questions based upon the formula E is equal to minus d phi over dt. EMF is directly proportional to voltage. EMF and voltages are same. Electromagnetic force, which we say EMF, and voltages are same. This is velocity. Velocity, relative velocity. Okay, this is basically the relative velocity. Coil is there, magnet is there. This is coming close, this is moving away. Magnetic flux is changing, either increasing or decreasing. So there is a relative speed of its movement. EMF is directly proportional to that. Oh, otherwise, voltages and EMFs are almost same. All right, start writing it from here. Questions we'll see based upon the formula. E is equal this formula. See class, written the question. Can I scroll it? Yes, Fadil and Shahid writing or have written?
I'm done.
Done, no? Okay, let us discuss the solution. Any answers, by the way? Magnitude and direction you have to find out of the induced current in the loop. See, this is a little lengthy question. It says that a current 3.361 plus 2t into 10 to the power minus 2 amperes increases at a steady rate in a long straight wire. A small circular loop of radius 10 to the power minus 3 meters has its plane parallel to the wire and its center is placed at a distance of 1 meter from the wire. So it is placed, this is circular loop is there and a straight wire is there, and what the separation from the center of wire to the rod to the wire is 1 meters. Resistance of loop is given as 8.4 into 10 to the power minus 4, and we have to find out the magnitude and direction. So see, for this we first have to draw a rough figure for this. See, if the wire rod is like this is the circular loop. Now, from the center till here, this separation is 1 meter. That was written in the question. This is the wire. Current must be flowing within the wire. Let's say I amount of current is flowing within the wire. This is the loop. All right. And magnetic field must be there. All right. These are what all are given in the question. Now, see, firstly, field due to the wire at the center, this we can calculate at this center. Because of the wire, at least we can calculate. What is the formula? Formula is B is equal to mu naught I by 2 pi D. Fadil, we'll be doing these in the class itself, though this derivation is not there, but this will help you. This weekend only we'll start with this, all this. So you will be able to understand this part. So magnetic field will be what? Mu naught. This is 4 pi into 10 to the power minus 7. So 2 pi is already there. So 2 pi and 4 pi will get cancelled, and that will become 2 into 10 to the power minus 7. Current is, how much current is flowing? 3.36 into 10 to the power. Okay, so let us take, let me write the current as I only. And what is the separation? Separation is 1. Because 2 pi already have cancelled. Fine. Now see, when I'm calculating the flux within the loop, formula of magnetic flux is B into A. Now B, area of the circular loop is pi r square. So this becomes magnetic field is 2I into 10 to the power minus 7. This is 2I into 10 to the power minus 7. This much Tesla will be the magnetic field. So magnetic field into pi will be there, 3.14. And 10 to the power minus 3 was the radius, no? Ha, 10 to the power minus 3 meters was the radius. So this becomes 10 to the power minus 6. So 2 pi, this becomes 2 pi I into 10 to the power minus 13. So this becomes 2 pi I. So see, this is the magnetic flux. Weber will be the SI unit. This is the magnetic flux, 2 pi I into 10 to the power minus 13. How have we got it? Magnetic field we have calculated at the center. See, magnetic field at the center we have calculated because of the influence of this wire. Because we know the separation, we can find out the influence of the magnetic field at the center. Once we have obtained the magnetic field, pi we know, radius we know, so we have calculated. Now coming to current. Firstly, induced current is actually what? The formula that we have studied, induced current is what? Induced current is d phi over dt. Right? This is what is meant by it. And what we have obtained is 2 pi. Now into 10 to the power minus 13, all these are constant. So what are left? Di over dt is left. See this I with this. So di over dt, this is left. We have the value of current. See, value of current, this is given in the question, 3.36, 1 plus 2t, and into 10 to the power 10 to the power, how much was there? Minus 2. So 10 to the power minus 2 is the current that is present. So we will differentiate it simply. This we can differentiate. See, if we multiply this, so this becomes 3.36 plus 2 into 3.36t, and this whole getting differentiated, and 10 to the power minus 2, right? So 3.36, this will already be 0 when you will differentiate it. 2 into 3.36, that will become 6.72. 1 will also be removed. So directly 6.72 into 10 to the power minus 2 di over dt. Understood this point? See, 3.36, when you are differentiating, it's a constant. So this will be 0. This is left. X to the power n becomes nx to the power n minus 1. So 2 into 3.36, that is 6.72t. When you are differentiating this, t to the power 1 is there, minus 1. So t to the power 0 becomes 1. And only this is left. So that's why this is left, and we had 10 to the power minus 2. First, tell me how we have obtained di over dt. Is this clear? Because we are towards the end of the question. Is it clear? Fadil, you there?
Yes, ma'am.
Okay. Now see, what have we taken? EMF's value we had, phi's value we had calculated earlier, di over dt also we have calculated. Now at least we can find out EMF. That was the main question. So EMF would be, it was 2 pi into 10 to the power minus 13, and di over dt is 6.72 into 10 to the power minus 2. This much is the amount of EMF that will be obtained. So 2 into this 6.72, this will be 13.44. Pi, let us leave it. This becomes into 10 to the power minus 15. 10 to the power minus 15 volt. This is EMF. So if you are finding the induced current, that becomes EMF divided by resistance. And resistance is also given, 13.44 pi into 10 to the power minus 15 divided by entire value of resistance, 8.4 something was given, no? 8.4 into 10 to the power minus 4, see. So 8.4 into 10 to the power minus 4. This is it. So how much this should be? Just check. 8.40, it will become around 8 if we take this. Just check it, how much this would come. I'll tell you the answer there. So this is clear. This is how we'll find out the, and yes, one more thing, when we are talking about the direction. So see, according to Lenz's law, we'll calculate, see, due to increase in current in the wire, flux linked with the loop will increase. Understood? Due to increase in the current, what will happen? Flux linked in the wire will increase. So in accordance to Lenz's law, induced current will be in opposite direction. So if this is moving clockwise, then current will be anti-clockwise. This is how direction you will determine. But in this question, more than direction, magnitude was important. So how did we solve this question? See, in order to find I is equal to E by R, 6 pi into 10 to the power minus 2. This is coming. Okay, 16 pi, no?
Yes.
16 pi
16 pi
into 10 to the minus 12, no?
minus 2.
Minus 2.
Yes.
नहीं, minus 2 कैसे होगा? Just check once again. I think it should be minus 12. This will become positive. Please check this power. Fadil, you also please check. Power I.
Yes.
Yes, ma'am, checking.
Minus 12, na? Just check, let me know
Yes, ma'am.
whether it's minus 12 or minus 2. Anyways, while you people are calculating, you can note it down later also, write down the solution first. So basic step is that I is equal to E by R. We wanted to calculate E, we didn't know. And in order to find E, we had to find out d phi over dt. Phi we calculated it using dA, and for magnetic field, we had used the formula of magnetic field due to a straight wire, because no information of magnetic field at the center we had. So this magnetic flux was calculated, di over dt was differentiated and calculated, and that's how it was finally induced current was calculated. Note it down and just confirm the answer also. 16 pi is correct. Just I'm not sure about 10 to the power, because I think it should be minus 12. Just check once again. Minus 12, no? Okay.